Good morning, students. In today's class, we have discussed next important concept. It is very important: reliability and quality. So, it is already well-known fact. Day by day, the demand of electricity goes on increasing, and the standardization of human also increasing across the world, because our every application directly depends on availability of electricity and quality of electricity and reliability of electricity. What consumer expects? Consumer expects uninterrupted power supply and with quality power supply, because they doesn't know what is the investment, what is the technology is needed, but they expect only quality of electricity as per their repayment in terms of tariff. And quality of electricity, because their electrical equipments what the consumers are using, those are specified for particular voltage and particular frequency operation. If any fluctuations in the voltage or any fluctuations in the frequency which will damage the performance of consumers equipments, in that respect the reliability and quality of electricity becomes an important concept we have to discuss. Very first of all, reliability is the probability that an item or a collection of items will perform satisfactorily under specified condition during a given period. So, entire power system is a integrated power system. It may consist many components. So, here reliability of individual or reliability of overall, it is a probability or it is a group of collections which works under satisfactory. From generation units to distribution of electricity, it should work very satisfactorily under specified time. And another definition also focus that reliability defines the number of interruptions in a power supply and their duration and frequency. I already told the consumer needs uninterrupted power supply and quality power supply, because they want do not affection or deformation of their equipments. That's all. Hence, reliability directly depends upon number of interruptions. Number of interruptions causes due to faults or outages. Faults or outages are very much important to cause interruption. If interruption is caused, how much duration it is required to come on the supply, that is called downtime. And frequency, because voltage and frequency variations are naturally expected in distribution of electricity. Hence, at the consumer point, voltage must be same, frequency must be same. This is called reliability. There are two methods are employed to determine the reliability level. One is called deterministic method, one is called probabilistic method. Complementary methods are also used to determine the reliability measurements. For example, already I told our integrated power system consists different components. There are many programs, there are many reliability are required. For example, ability to operate within applicable limit for N1 contingency events for transmission and SIFI and KID for distribution systems. This is shows the design of one distribution system. It should operate for only one contingency. One contingency means first time fault only. If the fault is not rectified, then N2, N3 contingencies are goes on increasing. Later on, it may cause the entire system shut down. The probabilistic methods are usually applied for generation systems to predict their demand. It will be well served. The power quality refers mainly management of AC bus voltage, waveforms at rated frequency, undistorted, balanced and rated voltage. I already told the power quality means the consumer voltage, the consumer's frequency without any distortion. That means frequency must be same. Indian standard frequency is 50 Hz. What is the rated voltage of supply? That should not also be cause much variation from the secondary of transformer distributed to consumer. It should be of same, or it should have less regulation which the consumer equipments are to be tolerated. This is one of the meaning power quality. This power quality is growing because as per the population increases, need of electricity increases, hence standardization of human goes on increasing in India and across the world. Hence power quality growth becomes very much important in 21st century, and it is also well needed in tomorrow's electricity market, because people are selecting which quality, which supply quality is good. One criteria, it may be on economical, another criteria next stands power quality. Which supply power quality is good, that company supply may be purchased by the consumers. This is one. In this respect, modern grids with advanced sensing and measuring technologies can deliver power different at different grades. It is one of the burden on utility. They have to maintain grid system in such a way that with the involvement of advanced sensing units, advanced measuring technologies which can improve the quality of electricity. And grid reliability plays a very important role in digital economy, and which ensures the competitiveness and efficiency of the power system. So, what we have discussed up to last slide, it is just introduction of those concepts. Now, as per your syllabus, we can enter reliability modes. This is first concept. A power grid is planned and operated in coordination manner to perform reliability under normal and abnormal conditions as per grid code. There are some grid rules are there, grid construction use codes are there. As per that code, the power grid should be such that during normal condition, during abnormal condition, system should have better quality of electricity. In this respect, we have to discuss number one, power. For reliable power, the system operation requires mainly two systems. Number one, SCADA system is essential. Number two, WAMS decision is also very much essential. These two systems are very much necessary. Second one, personal responsibility. As the technology changes, the manual resources to handle the bulk power system should be also trained, well planned. So, power system engineers are to be planned and operational, interconnected of bulk power. It may be suitable software, it may be man intelligent, it may be handling of advanced metering technologies. Hence, personal responsibilities are to be trained. Next one, cost effective demand. Responses of resources are having potential to enhance the electricity system reliability. And also nowadays the need of electricity is increasing. The grids are so much designed to absorb the renewable energy resources. Next one, energy efficiency. By controlling effectively the electrical equipment's use on consumer side or demand side, if we can effectively control by energy efficient device, or energy saving schemes. This method reduces the power system operation at peak load condition. If it reduces, then it also reduces the investment on reliability condition. It increases the reliability. That means these implementation of methods will cause less investment on the reliability, because system only provides best reliability. If all the equipments are operating less than their operating condition, then there are less chances of shutdown or interruption. Hence, it indirectly increases the reliability of the system. The energy system will become more reliable and resilient, another term, because of energy storage. The distributed and modular renewable systems are less chances to cause the large scale failure systems. Hence, we have to concentrate on these points. Thank you, one and all.